We'll start with a discussion of structure pop quiz doubts. And this was a structure pop quiz 19. In the first question, some reactions of halogenoalkane are summarized in the diagram. As you can see, a halogenoalkane is converted into alkyl amine, converted into alcohol, and reacted with KCN and ethanol. Name the type and the mechanism of this reaction. So whenever like halogenoalkanes are reacting with these reagents, there are two possibilities are there. It might undergo a substitution reaction or elimination reaction. But if it's an elimination reaction, that only happen or occur when a potassium hydroxide or a sodium hydroxide is there in alcoholic medium. So we have to state what is a type. So what is the type of this reaction? It is nucleophilic. And the mechanism is a substitution. So this is these all are nucleophilic substitution reactions. If it was elimination, then the halogenoalkane will form an alkene, but it is not forming alkene. And when it form alkene, there should be a potassium hydroxide or a sodium hydroxide in alcoholic medium. Give the iopic name of the structure of compound M. So how we can name this compound M? Because first we'll complete a product. So what will the product? The CN will take position of a BR and a BR will take position of. So what will be the product? It will be a substitution reaction. So the product, the structure of M, it will be H3C, C, CH3, CH3 and CN. When we name a compound, we always select the longest carbon chain. So which is the longest carbon chain? Maximum we have 3 carbon here. And we have to include this carbon with the nitrogen, triple bonded. We have to include that because that is a functional group. So the numbering should start from this carbon. So this is 1, 2, and 3. So second position, we have 2 carbon chains. 2 groups are there, which are carbon chains. So this is 2, 2. Because methyl groups are there, so dimethyl. And 3 carbon, it will be there, prop, single bond N, and nitrile. Because of CN, it is nitrile. Even if you select a carbon chain, either top or a bottom, the name does not change. How the name will not change? Let's say you took one of the carbon on the top, or you took one of the carbon at the bottom. The name will not change. When we select the longest carbon chain, let's say another student selected this as the longest chain of the carbon. So if this is the longest chain of a carbon, 1, 2, 3. So second position, again, 2 branches are there. So the name will be same. That will be 2, 2 dimethyl. Yeah, it has to be with CN. Why it has to be CN? Because that is now a functional group, the nitrile. And that will affect the chemical properties. That's why we cannot exclude this CN. It has to be there apart. So the iopic name for this compound is 2,2-dimethyl propane nitrile. State the reagent and the conditions required for reaction 1. Whenever we want a substitution, like we want to replace this halogen attached to an alkyl group by a amine group like NH2 group. So what we need? We need ammonia. And what ammonia we need? What is the condition we need? It should be heat in a sealed tube. But what is the condition? That's right. In a sealed tube we need. But what else is a very important thing? We need alcoholic. So alcoholic ammonia will result in a substitution. So it's important to mention the reaction conditions. So one they ask the reagent, we'll mention ammonia or NH3 we can mention, and it should be in a sealed tube in alcoholic solution. So it is important to mention these conditions. For a substitution reaction, there are certain conditions when you want a substitution of amine group to a halogen. The condition is that it should be in alcoholic medium. The main reason is that because halogenoalkanes are not water soluble, as they cannot form hydrogen bond. But in alcohol, both can dissolve. Ammonia can dissolve in alcohol because it can form a hydrogen bond, and halogenoalkane can also dissolve in alcohol because it will have a dipole-dipole force. That's why we mix them in alcoholic medium, the common medium in which two can. If it was aqueous medium, so the halogenoalkane does not mix easily. The next is an incomplete mechanism for a reaction 2 is shown. Complete the mechanism by adding curly arrows and the relevant dipoles and the lone pair. So we have to show this like first a partial positive and a negative because halogen are more electronegative. So this will be have a partial negative and the carbon will have a partial positive. And then first what will happen? This is a tertiary halogenoalkane. In a tertiary halogenoalkane, SN1 reaction happen or occur. In SN1 reaction, first the bond will break. It will form a carbon cation. So first the bond will break. This carbon will break a bond. So we'll represent an arrow from where the electron started to a position where which atom takes those electrons. Then this form a carbon cation. It's a tertiary carbon cation which is more stable. And now the OH with a lone pair will attack on this carbon cation. As a result, it will form an alcohol and we have a bromide ion is released. That's how we complete this mechanism. Describe how the intermediate J is formed in the first step, naming the process that occur. So first, what kind of bond breaking happen or occur here? As you can see, one positive ion is produced, another one negative ion is produced. So whenever a covalent bond break down and forming a cation and an anion, so what we call this, we call that as a heterolytic fission. So this will be a heterolytic fission. No, in this carbon is having a plus charge. Why it is having a plus charge? Because it is electron deficient. How it electron deficient? Like these are the four electrons of the carbon. This is representing the electron of the other groups. So the bromine, which is more electronegative, take both of these electrons. If you want to show like this bromine with these electrons as well, that is also fine. And because the carbon has lost its electron, that's why there's a plus charge. So this lone pair is attracted and form a bond. So how intermediate J is formed? So the formation of intermediate J it's because of the heterolytic bond breaking, or we can also say a heterolytic fission, because the electron pair is transferred, like electron pair which was shared between a carbon and a bromine is actually transferred to bromine atom. So we'll state here heterolytic bond breaking happen and the electron pair which was shared between the carbon and a bromine is transferred or moved to bromine. That's why a bromine is having a negative charge and the carbon is having a positive charge. Is it clear, this one? The next, state the shape of the intermediate. How you and justify your answer. Whenever you predict the shape, you have to check the bond pair and the lone pair. And check the central atom. The central atom is a carbon. This is the central carbon atom. So how many bond pairs do you see? 1, 2, and 3 bond pair. So it has a 3 bond pair. And how many lone pairs are there? There is no lone pair. So whenever a molecule is having 3 bond pairs and there is no lone pair, so what will be the geometry? The geometry will be trigonal planar. So this will be trigonal planar. And explanation, what is explanation? It is always based on the valence shell electron pair repulsion theory. What it state that there is a more like lone pair, if 2 or more lone pairs are there, they repel more than the bond pairs. So it has 3 bond pair and there is no lone pair. So the atoms or the the bonds will align so that it minimize the repulsion. So your structure of the answer, you will mention it has 3 bond pair, no lone pair. So the atoms will arrange in the bonding to minimize the repulsion and it will have a trigonal planar shape or geometry. But if the same question was there, let's say this substance X was there. And if they ask what is the geometry of this substance X, so what will the geometry? The central carbon atom is having 4 bond pair. So when there's a 4 bond pair, the bond angle will be 109.5 or it will be a tetrahedral structure with a bond angle of 109. An explanation will mention it has 4 bond pairs and there is no lone pair. So the atoms will arrange to minimize the repulsion. So your answer should be very structured whenever you're comparing the bonds and the structure of a molecule. The product of reaction 2 is shown. So when reaction 2 happen or occur, this is the product shown. This compound has 3 isomers. So this compound is having 3 isomers. Draw the structure of these isomer. We have to draw, this is, and whenever isomers are there, they will have different names as well. Actually, what is this compound? Second, if I select the longest carbon chain, I can select like this, so 1, 2. So it is 2-methyl propanetol, the name of this compound. 2-methyl propanetol. That is the actual name of this compound. Now, we just have to rearrange the structure. Like what we can do, we can draw the straight chain. We can draw OH with the first carbon. And we can also draw the straight chain and we can draw the OH with the second carbon. So as they ask us to draw, so what we can do, we can draw a straight chain. And as it's not mentioned what structure, like sometime in a question, they ask specifically that draw the displayed formula, draw the skeletal formula, draw the displayed for structural formula. But in this case, it's not mentioned. They just ask draw the structure, so we can use any of them. So let's say I took 4 carbon, 1, 2, 3, 4, and then I attach OH here. That is one isomer. Then I just change the position because I need 4 carbon atoms. So 1, 2, 3, 4, and OH is attached with the second carbon. That is another isomer. Or you can use this as your second carbon. So that is a second isomer. Then you can have, because here the OH in the branch is attached with the same. So drawing the structure. So 1, 2. This one is branches there and the OH might be attached with the first one. So OH is attached here, 1, 2, 3. So in second position, we also have a branch. So this is another structure of So these are the three isomers. You can draw the skeletal formula or you can also draw the structural formula. The reaction of halogenalkanes with hydroxide ion is often carried out using a sodium hydroxide or a potassium hydroxide. The alternative is a moist silver 1 oxide, which is prepared by adding few drops of a water to a silver 1 oxide. Silver 1 oxide is insoluble in water but produces sufficient hydroxide ions for the reaction. So one way of this reaction is providing a hydroxide ion by using either sodium hydroxide or potassium hydroxide. The other is we can use a silver 1 oxide also to produce the hydroxide ion. When silver 1 oxide is dissolved or mixed in water, but silver 1 oxide is insoluble but produce a sufficient hydroxide ions. Write an ionic equation for a reaction of a silver 1 oxide with water. State symbols are not required. So what will the formula for silver 1 oxide? Silver valency is given plus and oxygen is 2 minus. So the silver 1 oxide will be Ag2O. Reacted with water, so H2O. What it is forming, because we want a hydroxide, so it's obvious that one of the product is hydroxide. If but like they mention here, it does not, it's insoluble, but slightly it can decompose. So as a result, there will be silver ions as well. Then balance the equation, two silver ions should be there, and oxygen is so we can put two, so hydroxide. So this will be solid. Here is liquid. Ions are always aqueous and aqueous. So actually what happened is silver 1 oxide is insoluble. So what does it mean? Like if we have like 1,000 molecule of a silver 1 oxide, out of 1,000, maybe one or two molecule will break down and produce a hydroxide ion. But that is sufficient for this reaction to proceed. As the water is always also there. The next is suggest one advantage of using a silver 1 oxide rather than sodium hydroxide or a potassium hydroxide. Look, when we were using for halogenoalkane, let's say this is a halogenoalkane, and we were reacting sodium hydroxide or potassium hydroxide, the OH was taking position of the halogen, so it will produce an alcohol plus sodium salt. But what if we were having excess of a sodium hydroxide, like more than enough sodium hydroxide? So if we have excess of a sodium hydroxide, this will be used up completely, but then we are left with these substances. So what we have to do, like sodium hydroxide is there, alcohol will be there, and a sodium salt. Then we have to carry out a separation. Like we have to separate. A separation technique is, and because they are all soluble, so it is difficult to separate the soluble substances from each other. Like we have to form one precipitate, otherwise it's really hard to separate them. But what is the advantage if you use a silver 1 oxide? Because when we use a silver 1 oxide here, the silver 1 oxide, when it mixed with water, it is producing a silver ion and the hydroxide ion. So as a result, when this hydroxide ion will react, like if this hydroxide ion will react, it will displace this. So as a result, it will form alcohol and then X will be there, which will combine with the silver. Now, because most of the unreacted substance or most of the unreacted silver oxide is insoluble. So what does it mean? If we add too much silver oxide, the silver oxide will not all dissolve. So what we simply do, we can remove the excess of a silver oxide by filtration. So this unreacted silver oxide which does not dissolve or which does not produce a hydroxide ion, we can separate it easily from the mixture by filtration. But here what happened? We unreacted sodium hydroxide or a potassium hydroxide cannot be easily separated. So that is advantage of using a silver 1 oxide rather than sodium or a potassium hydroxide. Is it clear? Part E1 and 2? In question 2, group 2 elements magnesium to barium are all silvery white reactive metal. Draw a label diagram to show the bonding and the structure of a group 2 metals at room temperature. So what is the structure of the metal? The metal consists of a lattice of a positive ion and the delocalized electron. But whenever you draw any diagram, it should always be labeled, like label the cation, label the delocalized electrons. Then explain why I did not label it, but you should always draw a label diagram. Why magnesium is having a higher electrical conductivity than sodium. So the electrical conductivity depends on the number of electrons in the system, like in the structure, I mean. So because magnesium will lose two electron, or magnesium will have more delocalized electron than sodium, that's why it has a higher electrical conductivity. So you can simply say magnesium has more delocalized electron than sodium in a unit volume. That's why the magnesium will have higher electrical conductivity. Write an equation for a reaction of a magnesium with a cold water. So when a group 2 metal is there, magnesium, it is reacting with cold water. Result will be a magnesium hydroxide plus hydrogen will be there. The magnesium Mg. So magnesium hydroxide plus hydrogen will be the product. Next is identify a single reagent that could be used to distinguish a separate sample of a dilute magnesium nitrate and a barium nitrate. So we know because barium sulfate is insoluble. So what we can add here, we can even add sulfuric acid. Like let's say we add H2SO4, aqueous sulfuric acid. So when we add sulfuric acid, magnesium sulfate will be formed. Most sulfates are soluble except calcium, barium, and lead. So magnesium sulfate is a soluble, so it will no visible change will be there in the solution. But if we add barium, like we add sulfuric acid to a barium nitrate solution, so it will form barium sulfate, which will be insoluble. So explanation here, it will form a white PPT with barium nitrate because of due to formation of a barium sulfate, and no visible change will be there with magnesium nitrate because magnesium sulfate is soluble. Describe what is observed when a strontium iodide react with a concentrated sulfuric acid. We know iodide ion is good reducing agent. What are the product the sulfuric acid can produce? Like what are the oxidation number the sulfur can have? In H2SO4, each oxygen is -2, so 4 will be -8. Hydrogen is +1, so 2 will be +2, so sulfur is +6. Now, because what are the products of a sulfur? It might be a sulfur dioxide. If it is a sulfur dioxide, sulfur will be +4, the oxidation number. It might be a sulfur, it means it will be 0. It might be a hydrogen sulfide, it means that with sulfur will be -2. So usually when it is reacting with iodide ion is good reducing agent. So it reduces sulfur to lower oxidation numbers compared to that of a bromide. When we react with a bromide, sulfur dioxide will be formed. But in this case, so what are the described or what is observed? So what is observed? Because there's a sulfur dioxide gas. So what is the appearance or what is the effect of a sulfur dioxide? We'll say a pungent gas because there's a sulfur dioxide. A sulfur solid is there. Whenever sulfur solid is formed, so what we can say? We can say like solid is formed because we just need observation. Usually sulfur is yellow, like sulfur is yellow, so you can say yellow solid. You can also say, yeah, misty fumes are also there because hydrogen iodide will form, or misty fumes are also acceptable. Then because of a hydrogen sulfide, this will be a rotten egg smell. These are the product of the sulfur. But what about iodine? Because when it is reacting, iodine molecule will also form. So what is the appearance of the iodine? Iodine, we can say a dark color solid, or you can say a gray solid will be formed. Or if it is vapors are there, because usually the reaction of a sulfuric acid with aqueous solution is exothermic. Like if you pour a sulfuric acid to an aqueous solution, it will give like exothermic reactions, so it produces the vapors. So it will be a purple gas or vapors, you can say. And you can also say misty fumes as well. But any two you have to write. And you can also say white precipitate because of strontium sulfate. Most sulfates are soluble, but for group 2 sulfates, as we go down the group, the solubility decreases. Like it becomes less soluble as we go down the group. So as a result of a strontium sulfate might form because the other ion was a strontium which might combine with sulfate. So white precipitate is also one of the product, like one of the observation, I mean. Next is a compound X anhydrous group 2 bromide is dissolved in water and titrated with a aqueous silver nitrate. So we took a silver nitrate, AgNO3. Here we have AgNO3. And we took this compound X and we carried out the titration. 0.25 grams of X, like the mass of X which was here, that was 0.250 grams, which was dissolved in water as I mentioned already. It required 33.65 cm cube and 0.05 mole per dm cube. So that we have the concentration and the volume. So using the concentration and the volume, we'll first find the moles of silver nitrate because we want to identify element X. Identify X, a compound, but X is a compound, okay? Now, how to identify this? We know group 2 bromide is there. So group 2 has a valency of a +2. So if group 2 bromide is there, it will be MbR2 because metal and then with a valency +2 and a bromine -1. So this will be a group 2 bromide. When it react with silver nitrate, what will happen? A displacement reaction will occur. Like silver will take position of this group 2. So this will be AgBr silver bromide, which will be a yellow PPT, which will be a cream precipitate, not yellow. Yellow is for iodide. And then a metal nitrate will be there, a group 2 nitrate will be there. The balance equation for this reaction between them, 2 nitrates, so we put 2. Rest all of them. This is bromine is 2 here, so we put 2. Rest all is balanced. Now what we will do, how we work out this total is called compound X, okay? This is a compound X. So using the concentration and the volume, first we'll find the moles of silver nitrate. After getting the moles of silver nitrate, we'll find the moles of this substance, the compound X. From moles of the compound X and the mass in gram of a compound X, we'll find its molar mass. Like what is the molar mass of this compound? And from molar mass, if just we can identify because we know the mass of a bromine. So if we subtract the mass of the two bromine, we'll know what is the mass of this element M. And if from that we can identify the whole compound. So moles equal concentration times the volume. The concentration is 0.05 and the volume is 33.65. But that should be in decimeter cube, so divide by 1000. So how many moles we get? Moles of silver nitrate. 1.68 into 10 to the power 3. Okay. So we got 1.68 exponent -3 mole. Then we'll find the moles of this compound X, but the ratio between them is 1:2. So if it is 1.68 exponent -3, so this should be X. Cross multiply. So it means this will be half of it, 1.68 exponent -3 divided by 2. We'll get the moles of this compound. What's the answer? 1.68 divided by 2, which is 1.68 exponent 3 divided by 2. That is 8.4 exponent 4. So 8.4 into 10 to the power 4 mole we'll get for the substance X. Now we have the moles. We'll find what mass of, because we also have the mass in gram. So we will know moles equal mass in gram divided by the molar mass. I can find the molar mass by the mass in gram divided by the moles. The mass in gram was 0.250 and the moles are for substance X is 8 into 10 to the power -4. So when we divide, we got 297.2. Okay. So 97.2 gram per mole. That's the unit of the molar mass. Now, after knowing the molar mass, if you want to work out which element is present, we know that X is what? X is the metal and the 2-bromine. So we know the total should be equals to 297.2. So each bromine is 79.9 multiplied by 2. So this substance is unknown. We cannot use X here already. The compound name is X. So if we subtract this value 79.9 into 2, and let's say this is substance M is there. So the M plus 79.9 times 2 should be equals to 297.2. If we move other side, we'll get the value for the M, which is 137.2. 137.2, when you check the periodic table, that is a mass of barium. So means this M is what? It is barium. So what is compound X? That was a question. So compound X is barium bromide. Is it clear? Discussion? So this was a question related to the structure pop quiz.